Problem 7. This is our challenge problem for the week, and it's a challenge because I haven't taught you the name or the term for the geometric relationship that you need in order to write this problem. But it's kind of what we call like an obvious one, but what you're missing is the name for it. It's one of those things. Once I show it to you, you're gonna be like, oh, well, of course that's it. How else could it have been? I just didn't notice it. It's like if I draw this shape. It's a terrible drawing. But if you look at that, what do you see? And you might say, "Oh, I see a rabbit, right? Like I see, a bunny rabbit. Like there are the ears." Okay. But what happens if I told you, "No, no, no, no. That's a duck, right? Quack, quack, right? That's the mouth of the duck, and that's the head." Okay. Once you see it, it can't be unseen. Whenever you see that image, duck and rabbit will come to mind. And that's the same thing with this problem. Once I show it to you, you can be like, oh, I know that thing. That's the thing. And I'm not going to spoil it. We're going to go through it, and I'm going to say, okay, well, this triangle, EKL, right there, and then the corresponding triangle, just the bigger one out here. We saw a problem like this, and I think it was number 4. Yeah, number 4. It was like that. But what's different about this one is you know nothing. You know nothing about the bases. All right, we're like Jon Snow. We know nothing. What we do know are these sides, the other sides. So we're definitely going to have a side and a side, and it's probably going to be an angle, but that's a big question mark because I don't see vertical angles. I don't see that hourglass. This is overlapping. But you know what? Let's persist. When you're not sure, do as much as you can. Do what you do know. And what I do know is side F E. Well, that's going to correspond to side K E. And well, when I look at that ratio, that will be 28 in the denominator, and the sum of 14 and 28. 42, right? 42 goes up there, and I'll evaluate that ratio in a second. And then the other thing I know is this big old side, E to G. All right, that side is 21, so they tell me, and that corresponds to this smaller side, E to L, E to L, and that side is 14. And I'm going to kind of clean this up a little bit, so let me get rid of this stuff now. And I'll type it in the calculator just to confirm. So 42, let me clear out everything. 42 divided by 28, 1.5, and 21 divided by 14, 1.5. That's how I know these ratios are equal. That's how I know those sides are proportional. And I'm just going to write that in my proof. Because that's something I can do. I'm confident in this. This is what I can do. So do as much as you can. My reason for writing these things are ratio of corresponding sides. The ratio of corresponding sides. Okay? And I'm just going to bolster the fact by saying that's a side fact and a side fact. I know this can't be side, 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 because I know nothing about that third side. This is going to have to be an angle thing. And I'll tell you what, if you were, persisting and using your gut, you know that angle has to be between the sides you're using. That's why I said persist. Just do it. Nike this thing. Your angle's got to be here. In this red triangle, all right, the angle you're going to use is angle E. Okay? I'll pull that out for you. Okay? And when you go to look at the blue triangle, the sides that you have are right now and there. And the angle has to be in between those sides. It's got to be angle E. And what can you tell me about that blue angle E and the angle E from the red one? They have to be congruent because they're the same angle. It literally didn't move. That angle is really flexible. It's in the smaller red triangle, and it's also in the bigger blue triangle. It's a dual purpose angle. It's a what I'm going to call a flexible angle. So that is my statement. That's the missing fact. That's the thing I didn't tell you, that I haven't taught yet, that an angle must be congruent to itself. And it just so happens that angle is used in both triangles, right? It's the in-between angle in the smaller red one and the similar larger blue one. And what we call it is when you go to give a reason, you can't say given because they didn't give you the congruent marks. I'll say like X marks the spot, that this angle in the red is the same as the angle in the blue. That's my personalized notation. Your reason for this, the mathematical term, is called reflexive. And the way I remember it is something that is reflexive is flexible. It can be used in one triangle, and it is so darn flexible, it can be used in a different triangle without moving, and that's the key part. Boom. That's how I know. That's my reason for saying those things are congruent. And now I've got a side, an angle in between, and the other side that traps it. So I'm ready to make my final statement. I'm ready to restate what they asked me to prove. Triangle EKL must be similar to triangle EFG. And how did I know that? That is the side, angle, side, similarity. So I hope you enjoyed that last challenge problem, that bonus problem. We'll see it again in class tomorrow. And I hope you enjoyed Ellias Academy day 45. I'll see you in class.